All right, here's our Geiger-Muller counter, and this is why it did not work. So here we have most of the electrical components. We have them all soldered on. We were a couple components away until we realized that we ran into an issue. The interconnected circuits, or the IC chips, these spider-looking ones, when we initially put them on, we did not realize that there were some notches in them that we needed to follow. And looking at the board diagram, you can see that there are some indentations in the markings that show that it has to go a certain way. So this is actually not the original one, the original IC for this one. This is the replaced one. So looking on the back, we can see that we were doing, I'd say, a fairly decent job at soldering. We got the volcano shape to form around the legs of all of the circuits. The issue came when we realized that this IC was broken. So flipping it over, we were trying to desolder it, but we ran into some issues. The IC chip did not want to come out at all, even with external help from another teacher and showing us how to use desoldering equipment and all that from the S-Tech building. Even she was struggling to remove this IC chip. So what we agreed upon was we would take some needle nose snips and we would eventually just cut it out, which we did. We cut the old legs off of the IC chip. And then the issues came for this was when we were trying to remove the legs from the holes, because looking here, you can see all the holes. These are called pads, and the cut out legs were stuck inside the pads. So even though we were soldering even though we were heating up the soldering around the pads and the soldering, and we were heating up the legs, even with that and taking some needle nose pliers, it was really difficult to pull the cutout legs out. So eventually we got most of them out, but as you can see, there were some issues. So two of the legs there was three legs that did not want to come out. Two of them did get removed, but they actually tore the pad with them. So like for this one, not this one, but when we were taking the needle nose pliers and desoldering it and we were trying to remove the legs did not want to come out, and eventually we actually ripped the padding off, which is unfortunate. It wouldn't have mattered too much on this back side because most of the tracks are the copper wire that connects all of the loads and the resistors together. The tracks are actually on this side, so it wouldn't have been too much of a problem even with the padding removed on this side. But the real issue came with this one. So on this other side, that was the most difficult one to remove. And the cutout leg would not get removed at all. So eventually we heated it up too much and it actually started to melt the circuit board. And we put a hole through it, and there's no way to repair it unless we get someone with more experience to physically remove the damaged copper wire track, remove this, replace the track, and then we can put a new one in. So we could have also tried to solder this side, but this new chip that we got from the teacher, it sits pretty snugly against the circuit board, so there's not really a way to get the flux down there to weld. So unfortunately, we did make some mistakes and we weren't able to fix it and replace it with this new IC chip. And the reason why that this is important, the notch going in the same direction for like this one, is because IC chips they're not purpose built, but they're very specific on each of the legs. Each leg has a specific function that needs to be followed. So putting it backwards causes it to not work. So these interconnected chips, they are basically just fancy transistors, right? They're just basically fancy transistors that have lots of them. You can see two of them right here. Now, transistors, they work as electrical switches. So if you see that middle leg in between them, that is working as a switch to allow current to go from the left and the right leg, because this is how they work. So by supplying electricity into the B pin, the middle one, it allows a current to flow through the C and E, which basically is working as like a logic gate, right? It'll only allow current to flow through if the B pin is powered. But these IC chips, the interconnected board chips, these are not purpose-built again. They are very complex. So by flipping them backwards, we're replacing the ground and the VCC as well as the logic gates that are built into them. So this VCC right here is acting as the B for all of the other logic gates right here, and then it connects to ground. So by having that backwards, we're trying to supply the ground going into the VCC, which does not work, and all of the logic gates are backwards. So we realized this pretty late, as we were almost done, with the circuit board. So scrolling through, we were reading the directions. We knew some of them had to go on pretty specifically. So like some of these capacitors, they have a long and a short side, the yellow one right here. They have a long and a short side, which signals positive or negative. So we knew a lot of these had to go on very specifically. Resistors, they can go on either way. But it kind of slipped our mind that the IC chips just had to go on a specific way. So we realized a bit too late that the indentation was supposed to match up with the picture that you can see underneath it. So that's why we had to, so because of this being very specific, we had to remove it, which we failed at removing because the pins, after we cut them out, they just got very stuck in there for some reason. And even the teacher we were receiving help from, she also struggled to remove the legs and told me to have a go at it until we accidentally melted one of them. So I was able to, while looking through this, I am able to see a list of components, which I also realized too late, but we can see a list of the components, and the U1 and U2 has specific components. So for this shorter IC that we destroyed, we can actually see that it's a timer. So, and because each of these is pretty specific, it would definitely not work to just flip it backwards, and it would just not work. So either way, it would have been an incomplete project and would have not functioned properly. But we did get a lot of experience soldering. Tech, Colton and I, we got a lot of experience soldering, desoldering. We got to experience the struggles of trying to work around electrical components, as we also kind of used the soldering rod to melt the plastic a little bit as we were trying to initially remove this. Yeah. So we definitely learned a lot. We learned our lesson about double checking and reading the rules carefully. And overall, even though this project was a failure, we did learn some pretty important lessons. And even though we were unsuccessful in getting this out, we still got experience soldering, and most of our welds turned out pretty good. All right. Thank you.